You've already learned how to draw the graphs of cos of x, sine of x, tan of x in the previous lecture. Now let's say I have a more complicated equation. By saying more complicated, let's say I have an equation that y is given by 2 sine 4x plus 4 plus 4. Now how will I draw the graph of this equation? How will I sketch the graph of this equation? You can draw it by putting in the values of x and plotting the corresponding values of y. But how will I sketch it if I don't have the graph paper, which is exactly required in your P1 maths exam? So for that you'll have to learn this general equation, which is y equals to a f bx plus c plus t. Now whatever your equation, the equation you're given, whether it is sine, cos or tan, we'll just have to compare that equation with this general equation. For example, here a is 2. I'll tell you later on that what a, b and c and d are significant for. A is 2 and let's say b is 4, c is 4 again, and d is 4. So a basically corresponds to the amplitude of your graph, right? Here the amplitude in this case, in this y equals to sine x case, here the amplitude is 1, right? Here also the amplitude is 1, right? But here the amplitude is infinity. So this equation, this general equation, is only used for sine or cos, right? Now here f is what? F is sine, right? This is f, right here. Alright, so b stands for, b is 2. B itself stands for nothing, but b determines the time period. For example, b is 4 right here, so 2 pi over b gives you the time period. Alright, the normal time period of cos and sine is 2 pi, and when we're using this equation, here b is 4, so that will give me 2 pi over 4, which will be pi by 2. So the time period of this graph, of this expression, of this equation, will be pi by 2, which means that it will repeat itself after every pi by 2. Alright, so C is, let me change the color, C is C is 4. C itself stands for nothing, but minus C over B gives us this phase shift. So phase shift is pretty simple. It is point from where the graph starts. For example, or you can call it as point from where the graph starts, or the horizontal shift of 0. So what do I mean by that? Now in this case, minus C over B, our phase shift is C is 4 and B is 4 again. So our phase shift is -4 over 4, -1. Now the graph is of sine, so this means that normally the graph of sine starts from normally the graph of sine is like this, right? But when it has a phase shift of 1, the graph will be shifted 1 unit, phase shift to -1, so the graph will be shifted 1 unit on the left hand side. For example, the graph will be like this. Alright, so 0 have been shifted -1, right? So 0 have been shifted 1 unit to the left because phase shift is -1. Here in this case, phase shift was 0. Here in this case, phase shift is -1. Alright. Now moving on to D. Now the D part, this one D equals 4. D signifies the vertical shift of the graph. Now what is vertical shift? This is simply the vertical shift of the equilibrium position. Right, now D in this case is 4. So a normal sine graph is like this, right? But D in this case is 4. So our graph will experience a vertical shift of 4 units. So if this was for 0, the normal graph starts from 0. But our this graph, this one, with the graph with a vertical shift of 4 will start from 4 instead of 0, right? Now if we combine all of them together, alright, let's revise a little bit. A stands for amplitude, B is 4, 2 pi over B stands for time period, C is 4, negative C over B stands for phase shift, which is this right here, D equals to 4, and D stands for vertical shift, which I have shown you right here. Now let's draw the graph of this curve. Y equals to 2 sine 4x plus 4. Y equals to 2 sine 4x plus 4. Time period is 2 pi over B, which is 2 pi over 4, which will be pi by 2. Alright, B is 4. This is A, this is B, and there was D2. Alright, this is F, this is C, and this is D. Phase shift is negative C over B, which in this case is -1. Vertical shift is 4. Is there anything left? No, there's nothing left. So let's draw the graph. Let's first draw the coordinate axis. Let's sketch the graph. I'm saying draw again. But we are sketching the graph. We're not drawing the graph. Drawing is the actual plotting of the points of the graph on a graph paper. But we are sketching them. We're not plotting actual points. We're just making a shape of what the graph would look like. Alright, so this is amplitude T, A is amplitude 2, this is our amplitude. So the first step is to draw the graph of this sine, just sine of x, f of x, right? F is sine, so I'll draw the graph of sine. It is somewhere like this. We will follow certain steps to make things a little bit easier for you. This is the graph of sine of x. This goes from 1 to -1, and this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, alright, and this is f of x, this is sine x, alright. Then turn by turn add a, b, c and d in it. So let's draw the graph of 2 sine x, alright. So 2 sine x will go from 2 to -2, its amplitude will be from 2 to -2, its displacement will be from 2 to -2. This is the graph of two sine x. Alright, now let's add the quantity b in it. Let's draw the graph of 2 sine 4x now. Now 2 sine 4x will have a time period of pi by 2, but it will go from 2 to 2, so it will be like this, 2 sine 4x. This is 2 sine 4x. Now let's draw the graph of 2 sine 4x plus 4. It will have a phase shift of -1. 2 sine 4x plus 4. So it will start from -1. it will be the same graph. This graph will be shifted 1 unit to the left of 0, to the left of origin 0. So it will be somewhat like this. Alright, this point will be pi by 2 minus 1, negative 1. Alright, this point right here. Then let's add the vertical shift 4 in it. So the vertical shift 4, it will make the 0 position shift vertically upwards 4 units. If this would have been negative 4, then the equilibrium position, this x-axis line would have been shifted 4 units downwards if this was negative 0. Now this is positive 0, so it will be shifted upwards. It will start from 4 instead of 0. If it starts from 4 and its amplitude is 2, it will go from 4 to 6, and from 6 to 4 back again, and from 4 to 2. Alright, because its amplitude is 2. So for that, I'm gonna just draw here, let's say alright, let's say this is 6, this is 4 right here, this is 6 right here. I'm going to cramp this up a little bit. So it will start from this point. I'm just shifting this graph, because this graph right now, this one, this was 2 sine 4x plus 4 is the closest one to this equation. Only this plus 4 is missing in this one. So I'm adding plus 4 to this. I'll shift this vertically upwards 4 units. So it will go from, it will start from this position, it will go 2 units upwards, it will go 2 units downwards from 4 till 2, right, then back again. Alright, I've shifted this graph right here, this in the brown line, 4 units vertically upwards. Alright, so that's how you draw the graph. Now let's do another example. Let's do an example of cosine. Let's say I have y equals to 2 cos 2x plus 2. The first step is to draw the graph of this function. That's it, with no modification. So let's draw the coordinate axis. Now let's draw the graph of cos x only. Basic graph. The graph of cos x is this. Alright, so this is from negative pi by 2 to positive pi by 2 to 3 by 2 pi. No, this is not 3 by 2 pi, this is just pi. This is 1.5 pi or 3 by 2 pi. This is 2 pi. Right, this is the basic graph of cos x. Now let's draw the graph of 2 cos x. Alright, so this graph of cos x going from positive 1 to negative 1. The graph of 2 cos x will go from positive 2 to negative 2. Alright, its amplitude will be 2. So it will go from positive 2 to negative 2. I'm going to cramp this up. So this is graph of 2 cos x. Now let's draw the graph of 2 cos 2x plus 2. Alright, so this was our A, this is our B, this is our C. There is no D here. D is 0. This is C. So time period will be 2 pi over B, which is 2 pi over B pi, and our phase shift will be phase shift minus C over B, negative C over B, which is negative 1. Alright, so let's add B. This will be 2 cos 2x. Alright, so it will be the same graph, but it will be cramped up. The time period of this graph will be from 0 to pi. Alright, it will be somewhat like this. Alright, now let's add the phase shift. So So the graph will start from -1, right? The 0, it won't start from -1, it is already from negative infinity to positive infinity. It will be just shifted 1 unit to the left of O. So this. This point right here, this point will be pi minus 1 because it shifted 1 unit to the left, pi minus 1. That's it. This yellow curve is your graph of y equals to 2 cos 2x plus 2 plus 0. Right? This is plus 0 and it is out of the bracket. Then in your exam, they'll only ask you to draw the modified graph of cos and sine, but not of tan. So you don't have to worry about that. But still, in the next lecture, we will do an example of the tangent modified graph.